This time I will discuss how to draw or use Mohr circle. What is Mohr circle? Now, what is Mohr circle? Mohr circle is a graphical way or using a circle we can transform our stresses inside any civil engineering or any structural paper. Say for example, to make it complicated at this time, say there is a beam here, and this beam has so different kinds of different types of load, and if we take a small element here, the stress on this element, stress here, say it is this sigma x. So to balance sigma x, I have to write another sigma x here. Say there is a stress on this two, sigma y, another stress sigma y to balance this one. Say I have some shear stress here also. Say my shear stress here is this way, shear stress. To balance this one, I must draw another stress here, and to balance it, another one here. Mathematically, this one and this one must be equal to be in equilibrium. This one and this one must be equal to be in equilibrium. Shear stress, they should orient together so that my element is in equilibrium. Now, in normal beam, sometimes this might not be present. If there is no stress this way, there might not be any axial stress here also as well. So many things may not be possible or may not present. But we are considering here a general case, so that we can use it for any type of stress combination. Even sometimes this may be this way, this shear stress may be downward, many different cases. So now here, this is the most common cases, and according to the sign convention, this is positive. So away from element, we assume away from element it is tension, so we assume positive. Shear stress this side upward, we consider this is positive too. Right here, positive. So shear stress on the right side upward, right vertical side upward shear stress, we consider positive. So that is our sign convention. Now, if this stress is that way, that means negative. If this stress is downward, that means negative. So this is our sign convention. So at the beginning, for an element inside a member, we draw a bigger picture. What is our stress condition? Then how to draw Mohr circle? So Mohr circle, to draw step number one, what we do? We set a axis. This is axial stress axis and positive this way. And then shear stress, we assume this way positive. This way it is positive. We assume it. Now, from the history, we started to use this sign convention. So it is like this. Now, if we could assume the other way also. That is not a problem. So better to be consistent with our book, with like other people. We should better to use this sign convention. Okay, let me make it bigger. So that yes, make it bigger. So that is sigma. Now, step number one is to assume this axis. Step number two. Okay, step number one done. Next step, finding the center. Finding the center of the circle. Now, how to find it? Center of the circle is sigma x plus sigma y divided by 2. Then 0. Center. This is my x coordinate. This is my y coordinate. That means center will be roughly somewhere here. Center. Then we have to find out our radius of the circle. How to find the radius? Which is r. R will be sigma x minus sigma y divided by 2 square, then shear stress square. So this value will be our radius. Say our radius is some value. So draw a circle. It's not a good circle, but it's okay. So this will be, say, our radius here. Anywhere. So that is our radius. Now, after drawing the circle, whenever it intersects with my axis, the maximum or this value we call sigma 1. This value we call sigma 2. There are some stories about sigma 1 and sigma 2. What is this? Sigma 1 is the stress where there is no shear stress on the x-axis, on the axial stress axis. So these two values are called principal stresses. What is this? Principal stresses. So if the question asks what is the principal stresses, it means sigma 1 and sigma 2. For three-dimensional body, we call sigma 1, sigma 2, sigma 3. So it is sigma 1, sigma 2. Some books use sigma 1, sigma 3. That is also okay. Yes, sigma 1, sigma 3 also okay. Or simple maximum principal stress and minimum principal stress. If my circle is go here, when it is here, if both are negative, if x negative, y negative, sigma x negative, sigma y negative, then my circle will be here. In that case, there will be very minimum, there will be maximum. Hopefully you understood. One is sigma 1, larger one, smaller one is sigma 2. That is the story about sigma. Other thing, you can see if I go that way, the value of the radius is also my shear stress max. Shear stress max, this value. So this value, what we call in plane maximum shear stress. In plane maximum shear stress. So that is the maximum amount of shear stress. Now, when there is in plane maximum shear stress exists here, that time what is my axial stress? Average center. So sometimes in FE exam you will see this question: when maximum in plane shear stress occurs, what is the value of normal stress? This is the value of normal stress when there is maximum shear stress. Other time it may be asked when principal stresses occur, what is the value of shear stress? Principal shear stress occurs, that time there is no shear stress because it is on the axis. So sometimes you might get this question: what is the value of 1 when other exists? This kind of question. So we learn how to draw a Mohr circle, how to look at principal stresses, how to find the maximum shear stress. Something else, the orientation. Orientation means now we know that sigma 1, sigma 2 or shear stress, there is some value. Now how it is located in this element? If it is this way or if it is this way, we do not know which angle. We can find the angle too. How? First we should locate our reference point, sigma x, sigma y. Say it is somewhere sigma x positive, sigma x, shear stress xy. Say this value is here, sigma x, tau xy, somewhere here. If it is here, and if we draw a line, okay, now erase some line to make it clean. Erase some line to make it clean. So you can see here this angle. This angle is called twice P1. Why twice P1? Theta P, orientation of the principal stress. 1 means stress on. So that is twice P1. Now how can we find this? Simple case. Just we can measure the angle. If we try it in scale. If we cannot Still though, symmetrically we can find it. So make a circle, then what right maybe here. So you can see, you can write tan twice theta p1 equals this value. What is this value? Again, this is this value. Shear stress divided by this value. Now, what is this value? You can see up to this is sigma x. Here to here we know that sigma x plus sigma y by 2. So here to here is sigma x plus sigma y divided by 2, and entire here is sigma x. Then this one how much? Sigma x minus sigma x plus y divided by 2. Or simply this portion is sigma x minus sigma y divided by 2. So this value is sigma x minus sigma y by 2. So sigma x minus sigma y divided by 2. So use this equation, we can find 2 theta p1. Now whatever the angle is, find the angle here, then divide by 2, we can find this angle. So we can find the angle orientation. That means if I go counterclockwise, that angle, that will give me, so counterclockwise this way, then we will find the principal stress 1. Then whatever sigma p1, if we add 90, that will be, that means here to here we'll get sigma p2. Why? Because here to here is twice theta p1 plus 180. So that means here to here is twice theta plus 1 plus 180. Total here to here. Clockwise is that way. Counterclockwise is measured positive in Mohr circle. So here to here is twice theta p1 plus 180 here to here. Then divide by 2, simply this plus 90 is theta p2. So you learn how to find theta p1, how to find theta p2. What about orientation of shear stress? Is here this angle. This angle we can easily measure because this divided by or we can use this divided by the radius, and that will be sine. If I take sine from this angle, we can measure this angle. Whatever the angle, half of this, that means if we rotate this way, that angle, we will get the in-plane shear stress. Okay, so that angle is twice theta s. Twice theta s. Only one is because that is the maximum value. We do not need 2 here. So whatever the angle is, that is twice theta s. Divide by 2, you will get theta s. It is clockwise, so negative, or tail clockwise. So I think I discussed all aspects of Mohr cycle. It is just the theory. We will practice some example. But again, anything vague here, I do not think anything vague here, because whatever the angle there, half of that is angle here. So whatever, so if my block is here, this is my line, if I, this angle, theta, that will be in that angle twice theta. So if you move twice theta, whatever it is, that will be your stresses here. So that is the connection between that and this. Again, and if we rotate clockwise some angle, say 40 degree. So this is our reference point. Say you are rotating here 40 degree. That means this is your line. You rotate here 20 degree. After rotating 40 degree, whatever the value you will get, that is the value at this plane, rotating 20 degree, half of the angle. Now, after rotating here, say you are getting this value. It has a value that way, this way. That value is here in this. Here. Okay, we will see an example. So let us wrap up now here. Yes, our example will make us clear. Thank you.